Yes, dear student. Now I come to the point. Actually, I told you just now, W work equal to FD cos theta. और theta 0 तो FD is theta equal to 0. Now you can see here one thing more. I am doing against here D and force. If force remain constant, force has fixed value with 10 Newton, 100 Newton, then body have to draw a graph between force and displacement. So that graph come like this. So how much work you done? W equal to Fd. Here force into displacement. Give this area under the graph. So here we get one concept. Work done by force can be calculated from force and displacement graph by calculating the area under the graph. But here force was constant, so simply we have to determine area of rectangle. But think if force is variable, point to point force vary करता है, increases, decreases, and so on. And you want to find the work done in displacement body from x1 to x2. So we have plotted the graph, force and displacement graph. My problem here is to explain you how to calculate the work done against variable force. So one method is this: we plot the graph between force and displacement, and now we, so area under graph gives us, area under force and displacement gives us the magnitude of work done, quantity of work done, area under VT graph, force and displacement graph gives the work done. If force was constant, so it was simple to find the area. But if graph is not straight line, it is a curve like this, maybe of any shape, maybe like this also, maybe like this also, then area under force and displacement graph have to be calculated. Suppose we have a graph like this. So what we do to calculate work done from x2 to x1 to x2? We divide this area under the graph in small strips of thickness delta x. Delta x is taken such that at point here and here, force has same value. If we come here, we take this strip also, then force has value nearly same. Then this is a rectangle. Suppose this is force I, Fi. So Fi into delta x is this much work done. Then we take other strip and so on and add them. So if force is variable, then we plot a graph between force and displacement. Suppose we get the graph figure 1. We get the graph as shown in figure 1. So to find the area under the graph from x1 to x2, what we do? We divide we divide the area in strips of small thickness, delta x. This strip will be a rectangle, and area of rectangle length into breadth. So the area under force displacement graph from x1 to x2 is given by, which is equal to work done, is equal to work done, and W is equal to F1 delta x plus F2 delta x plus F3 delta x plus so up to, suppose we have divided n strips. Here delta x same. In notation we can write solution I equal to 1 to n Fi into delta x. Now this is the work done. If delta x further taken very small, if delta x is again taken very small, then equation 1 is written as W is equal to integration x1 to x2 f dx. This is called integration method of calculating the work done. Integration means to add a small part together. When a big quantity is subdivided into small parts, like our India is divided into different states, adding them all together become India. So integration means addition. And we generally speak about integrated country. We don't allow any state to get separated. That is our integrated. So integration from, you will learn which later on it will be the matter of situation how the force vary with x. Suppose in figure 2 this force is linearly dependent on x, increases regularly. In figure 2, W is equal to area under the graph from 0 to x, work done by force in displacing the body from 0 to x is given by क्या भाई W बराबर हाफ बेस x into height x हाइट यहाँ पर x पर फोर्स होता है ये F मान लो, तो इट इज half F into x also. Here F is 0, here F is equal to F. So 0 plus F by 2 may be termed here as average force. So somewhere where force is varying linearly, we can use the idea of average force. Here area under the triangle, तो half area triangle होगा, but I write here. But F here, half F means 0 plus F by 2 is equal to, we can write average force. So work can be obtained by concept of average force. W is equal to F bar लिख सकते हैं उसको, F bar into x, यानी कि average force multiplied by distance. This concept is also used in many cases to find the burden, but where force varies in random manner or not linearly, there we use integration method in calculation of burden. I hope you have got the concept of work here. Basically F dot D, general definition work, F dot D. But problem came here that force may not be constant. If force constant, then it is simple. Force into displacement and whatever the angle between the force and displacement can be multiplied together. But if any force there, then work can be calculated by different method, by finding area under graph or integration and then average force. Unit of work I have told you, joule and arc. Joule is not a big work, I mean, it is not a big unit. But as a unit, MKS unit is joule. In next video, I will be defining power and units of power. Thank you.